Probably just killed something.
All right, well, we're going. Did you want to start in on it, Brad?
Sure. So it's Friday, January 30th, 2015, and we're in the middle of NRGY 243, Fundamentals of Photovoltaic Installation. Connor's on the other end in Bozeman, and we're trying to record this both with iTunes U, Camtasia, as well as Blackboard. So this first lecture is going to be Connor just going over the material or the syllabus, and then we'll do another lecture on diving into the material. So go ahead, Connor.
Okay. Well, hello, everyone. Welcome to the class. Just posted a little introductory message to everyone last night on the class shell. Should get email notifications in your emails, but I encourage you when you get those to check out the announcements. I often will use that function for posting new materials to the shell or announcing the illumination of a week's materials. I tend to do them 1 week at a time, and so please keep your eyes open for those announcements. But I guess I'd start just by sort of repeating what I wrote in my message last night, just to talk about myself a little bit first. I guess this is my third semester teaching this course. As Brad mentioned, I live in Bozeman. I've lived in Bozeman, I've lived in Montana since 2002, and in Bozeman since 2004. I grew up in Vermont, went to Millbrae College, and that's actually where I became interested in renewable energy with my senior work in environmental econ, and studied some wind energy projects and some off-grid solar projects in Vermont at that time.
Have you done this at all?
And after moving to Montana, I ended up going to Solar Energy International, which is another very well-respected renewable energy education centers in the country, and took a couple classes in solar and wind, and just 2-week workshops, a similar focus to this class, and ended up getting a job in Bozeman right after, and have been working in the field here in Montana since, designing and installing mostly solar systems, both grid tie and off-grid, battery-based applications, generators, some wind turbines, and also became an active part of the Montana Renewable Energy Association. Started going to meetings there in about 2005, and 2008 became a board member, and 2010 became president. I'm still president. This is my 6th year in that capacity, so I'm actually kind of hoping to pass the torch next year and focus on other things. But it's been a great organization to be a part of, and I encourage you all to check it out. In fact, their website is montanarenewables.org. And also became NABCEP certified in 2008, and that's going to be a focus of this class for you all, is to understand sort of what the materials and training are that are required for pursuing a NABCEP certificate, sort of becoming tuned into the course or the path that's required to make your way towards taking the NABCEP exam. This class will culminate with taking the NABCEP Certificate of Knowledge exam, which is sort of like a entry-level version of the normal NABCEP exam.
Sorry, that was me, Connor. I didn't know I could control the board.
You're moving it out? Okay.
It's okay. That's all right. We're hearing you just fine, by the way. Everything's going great on our end. I didn't realize that we could also control the PowerPoint. So sorry about that. But go ahead.
Well, you can. I have you as a moderator, Brad.
Yeah, neat. Okay.
Yeah, I have a whole PowerPoint there, but only a few slides are relevant for.
That's all right. That's all right. We're having fun with it. Go, yeah, keep going.
Anyhow, that's, now my company is called Onsite Energy. Yeah, currently my business is called Onsite Energy, and I'm partner owner with my business partner Orion Thornton, who's another industry expert, and he also teaches online solar courses for SCI in Colorado, Solar Energy International. So we anyhow, I enjoy having a little bit of a educational, wearing an educational hat on the side of just developing solar projects and advocating for renewable energy in Montana through the MREA. Another interesting thing I just comment on real quickly is we're currently in the 2016 legislative session, and the MREA is a major player along with other groups like MEIC and the Montana Environmental Information Center, Northern Plains Resource Council, Alternative Energy Resource Organization, AERO, and those are the groups that are up in Helena lobbying on behalf of this energy sector in our state, trying to expand our market for more renewable energy implementation in the state, and trying to defend other policies that we already have working for us, such as our current net metering policy and certain tax credits and incentives as well. So that's another part of what I do and am involved in, and I would encourage anyone who's interested in any of that to access me for information in that regard as well, in addition to the more technical focus of the class here on the systems themselves. So transitioning a little bit here, if we could, last I knew, we were not able to, let me see if I can do a new page here. We were not able to load PDFs, believe it or not, to Blackboard last year. Well, how about this? I'm going to do a screen share.
Yeah, that'd be great.
Syllabus.
Yeah, that'd be fine. Yeah, I think in Blackboard maybe it just wants to see PowerPoint slides, but you can definitely do a full screen share, and that'll just show whatever you're looking at on your screen inside the Blackboard software.
Okay, let me pull that up real quick here.
Looks like it. Can tell when I'm talking.
Can you see my desktop now?
Let me take a look here. I might have to click on. Oh gosh. I think we can. It's not looking that great, but yeah, it's coming through. It's coming through.
But not looking very good?
It's okay. We can see it. It's
All right, well,
I had to do a screen share and sort of getting that infinite screen in a screen kind of deal, but we can see the topic outline okay, Connor?
Okay. Maybe I can zoom in a little too. So this week, so what we have here is a 15-week semester. We are culminating in our final exam May 11th. And I went through and updated all the dates should be correct for this semester as far as, and these dates here, like I said, this week, January 26th, that's the Monday of this week. So we're using the Mondays of each week as identifying what week we're working on. Spring break is the week of Monday, March 30th. So we'll all be off then, obviously. But between now and then, we've got week one, our sort of an intro to PV systems today, and I'll kind of go over some broad topics about the technology, markets, PV markets in our country and globally, as well as some of the finer details of how PV electricity actually works. Next week is an interesting course, solar radiation. That's a lot more of what you would expect from a much more scientific analysis of the radiation, the energy that we actually are getting from the sun. Week 3, site surveys and pre-planning. This is where sort of a lot of the work that I do for a living comes into play, and going out and assessing sites and developing projects with customers. Week 4 would be components and configuration, February 16th. So talking a lot about the components of the PV systems. Week 5, cells, modules, and arrays. That's sort of an interesting perspective on electrical theory in the ways of understanding IV curves, voltage, in contrast to amperage, which is current, building certain voltages and currents electrically by wiring modular things like solar modules and batteries in either series or parallel. So that's really it's very fundamental to a lot of the solar design theory that we work with every day. Week 6, batteries, week of March 2nd. Some of the types of batteries that we use and what we're trying to achieve by using batteries, and then a lot of the technical details about how to properly install and operate them.
It's okay. It's just
Charge controllers, week 7. Inverters, week 8. Those are two of the major balance of systems components for photovoltaic systems that are necessary or critically necessary for being able to utilize PV electricity for different applications. Then week 9 over here for spring break, system sizing. So understanding, this is very important for developing projects, understanding a load of a home or some kind of a standalone application in some cases, or a lighting system, and then understanding how to properly assess your solar resource and conversely size the system properly so that it actually successfully meets your expectations of what you're trying to do, empowering that load over time. So after spring break, we can come back. That would be week 10, April 6th, talk about mechanical integration. This is an interesting topic here and week 11, electrical integration. When you study for the NABCEP exam, 2 of the primary areas of content studying for the exam are what they call adapting the mechanical design and then adapting the electrical design. And in any PV system design, those are sort of the 2 primary areas of analysis that have to be thoroughly examined and figured out for any project. So, ground mounts, roof mounts, tracking mounts, understanding when those applications are most suitable to any one project, and then calculating the proper and figuring out the proper installation methods of those for every project, as well as the electrical design, and that goes back to the system sizing that we saw in a couple weeks prior in this syllabus, and understanding how to properly wire or how to properly size the system to work correctly. And then this electrical integration here has a little more to do with some National Electric Code requirements for safely and efficiently installing systems with proper wire sizes and conduits and disconnecting means and grounding a major topic. So that's actually quite technical there, but certainly, again, in approaching a NABCEP certificate of knowledge exam, or eventually the regular NABCEP exam, that's going to be what a lot of the more difficult questions will be on, actually. And so that's an important area to study.
Getting the final weeks here before the exam, utility interconnection, permitting, and inspection. There's actually quite a lot of references there to the National Electric Code as well for proper integration of systems to the grid. Proper methods to get the system project or getting the projects permitted properly with your local jurisdiction, or what they'll call authority having jurisdiction. That's kind of an industry term, AHJ. And then inspections, of course, by the AHJ, which is the living inspector. Week 13, last one, commissioning, maintenance, and troubleshooting. This is actually some of the more, in my opinion, some of the more interesting material, or some of the more fun work to do on any solar project is actually, okay, now the whole thing is installed, well, let's turn it on and see what it does and play with it and test it and make sure that everything is working accordingly to plan, and also recording data, so taking initial data sets based on things like solar irradiance and temperature and time of year, and really kind of calculating off those coefficients to make sure that your system's producing what it should be right at any one time based on measurements that you're taking of solar resource and temperature, etc. And then lastly, economic analysis. This is more interesting on a general market perspective. So for those of you who are, a little bit more inclined to understand the economics of solar projects or the solar industry as a whole, or perhaps the solar industry in contrast to other energy markets like natural gas or coal, electricity production. This is information that will be very interesting to you, as well as any solar project that we'll do. Some clients more than others are really interested in things like return on investment and payback, and long-term maintenance systems. And this is important, an important part of solar projects that needs to be understood, and so that you can convey to those people those bits of information that they're seeking. That in many cases they make or break the project happening at all. So it's a pretty important part of the picture. And then lastly, week 15, finals, May 11th, we do, NAVCEP has allowed us to use the NAVCEP entry-level exam. Brad Layton has worked on that in the past and has been able to set that up for this course, and has probably more information on that than I do. And actually getting registered for it and the logistics of taking it is something that our admin staff at Missoula College have been able to administer over the past as well. So perhaps this year Naomi Franson would be right for that, Brad?
That's correct. Yeah, she's. We'll train her on that, but she's at the helm on that one. So we'll keep everyone in the loop as that progresses. Yep.
Okay. So that's the course in a nutshell. The syllabus is posted online on our platform, right at the top of the class Moodle shell. If anyone has any questions, but by all means give me a call. And important to understand also, I will add that the primary textbook for the course is listed a little bit higher here. I don't know if you can see this material too well on my screen, but
we can see it okay.
Photovoltaic Systems by Jim Dunlop. Is that right? The ISBN number is listed right there. We will, every single week, we'll go through a chapter of the textbook. And Jim Dunlop is one of the initial authorities on photovoltaics in the country. And he started working at the Florida Solar Energy Center in the early 80s. and was a union electrician as well, an electrical engineer. And his book is really well written and very detailed. It also comes with a CD-ROM, interactive CD-ROM. Sometimes I like to use that for some of the slides that he has in there, some of the videos. It's kind of a nice presentation of those concepts. Anyhow, we'll go through one chapter per week. And the chapters are sort of technical, so I encourage you to start early and take your time and by all means, and I will go off those chapters in the lectures as well, so that's going to be an important part of the class. One more thing I thought I should mention is grading. We have written here assignments are 20% of your final grade, quizzes 20% of your final grade, exams 30%, and the class project 30%. So each one of those weekly chapters will have some correlating homework or quiz each week, and you can take them right out of the Moodle shell. So those are important to do, and I encourage you to do those on time so that to avoid penalties for late work. The exams they're much like the quizzes, but maybe a little more complex, so there's a little more weight on those. Well, the final exam, I apologize, let me back up. That exam is largely just the NABCEP exam, so that's a big portion of the grade. And the class project is something that I think people have gotten the most value out of over the last couple of years, and that's where they actually are asked, where the students, you're asked to go out and sort of find a solar project application and sort of develop the feasibility study of it and calculate how you would install the system and provide photos and design documents. And we do have past class projects to provide as sort of references for you when you do that, so you get a feel for, it's much like submitting a lab report. So, but that's a more applied requirement of the class, and one that I think people get a lot out of, and certainly it's an important part of your final grade too. So I think that's about it for the syllabus. Brad, do you want to add anything to that, or?
No, I think that looks like a perfect overview, Connor. When Joe and I wrap up here, we'll make sure that we've got textbooks for sale in the bookstore. Sometimes there's problems with that. We'll make sure everybody logs in and gets their intros up. Joe's got some kind of interesting background. He's just come back from Belize, where he's got some neat opportunities there to get those guys up to speed on reliable energy with their existing technology. But no, other than that, I think we're good to go. Like I said, we'll work here with Naomi on finding a room, because I know we've got more folks in the lecture than just Joe here, who's here today. So we'll I think 10 o'clock on Fridays is going to work fine. And I'd really like to sit in on the lectures too. So no, I think we're off to a good start.
Okay, great.
Yeah, so I'm gonna pause the recording, just the Camtasia on my end, and let that guy upload, and then we'll start up again here with the recordings in 3 or 4 minutes. Does that work?
Yep, that sounds good.
Perfect.